In this video, we will discuss about RL's circuit. RL denotes resistor and inductor connected in circuit. The combination of pure resistor R in ohms and coil of pure inductor L in Henry is called RL circuit, and a circuit possessing resistance and inductive reactance with pure resistor and pure inductor connected in series together is called RL series circuit. Here in below drawing, a resistor and an inductor is connected in series. The end terminal of resistor is connected with start terminal of inductor. Here potential difference of V is applied across series connected resistor and inductor. The voltage drop across R is the product of current and resistance, that is VR is equal to IR, and the voltage drop across L is product of current and inductive reactance, that is VL is equal to I into XL, where XL is 2 pi FL. Vectorially, in pure resistor, VR is in phase with current I. If we consider current as a reference vector, then VR neither leads nor lags the current by any amount. So we can see vectorially the current direction and voltage direction is same in and across resistor. Now in pure inductor, VL leads the current I by 90 degree. If we consider current as a reference vector, then VL leads the current by 90 degree. That is, VL is ahead of I by 90 degree. The voltage VL leads the current because due to transient behavior of inductor acts as open circuit, which does not allow current to flow from it, but has voltage across its terminal. Hence voltage leads by current in inductor. If we draw a vector diagram, combination of VR, VL and I, then the phasor diagram will appear as per this diagram. Here I is reference vector, VR is in phase with I, that is the angle between I and VR is 0, but VL is leading current I by 90 degree, being pure inductive reactance. If we draw the magnitude of VL from end of VR, the vector diagram will appear as per this diagram, which is right angle triangle having three sides V, VR and VL. This is the resultant magnitude of applied voltage V across the RL circuit. Here V is equal to product of I and Z, where Z is the impedance due to R and XL. This is phase difference by angle phi, that is V leads VR by angle phi. This is voltage triangle of having sides VR, VL and V. From this voltage triangle of RL circuit, we can write an equation as by Pythagoras theorem. V is equal to square root of VR square plus VL square. As V is equal to IR and V is equal to IXL, VL is equal to IXL, so we can write next equation as V is equal to square root of IR square plus IXL square. After solving this equation, we will get as below. V is equal to I into root of R square plus XL square. So finally V is equal to IZ, where Z is impedance and it is equal to root of R square plus XL square. This impedance is the total opposition offered to the flow of current in an RL series circuit. It is measured in ohms. With this equation of V is equal to IZ, we can also write Z is equal to V by I and I is equal to V by Z by Ohm's law. By this equation, Z is equal to root of R square plus XL square. We can make the impedance triangle also as per this drawing below. Here R is resistance, XL is inductive reactance and Z is impedance. And by Pythagoras theorem, square of R and XL will be square of Z. So Z will be the square root of R square plus XL square. XL is inductive reactance and it is equal to 2 pi FL. F is the supply frequency in Hertz and L is inductance in Henry. This angle is called as phase angle, denoted by phi. By this triangle we can write the equation as tan phi is equal to VL by VR, and that is equal to IXL by IR, which is equal to XL by R. Phase angle phi is equal to tan inverse of XL by R. Sinusoidal waveform in RL circuit. The waveform of VR and I starts from origin and increases simultaneously, and both of the magnitude of VR and I reduces at the same time. But the waveform of VL is already of magnitude VL at origin. This is indication that VL is leading VR and I by 90 degree. Here VR and I increases and decreases at the same time, but VL magnitude of increasing and decreasing is 90 degree ahead, and in this way the waveform continues on the x-axis, and at every point on the x-axis we can see VL is leading by VR and I by 90 degree. This is all about RL series circuit. Please subscribe my channel, and if you have any question related to RL series circuit, please write in comment section. Thank you.